Welcome to Almost Here, Round the Corner Future Technology podcasts with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcasts. I have Michael A. Grandner. He's a PhD. He works at the University of Arizona College of Medicine. He's the director of the Sleep and Health Research Program. Mike, how you doing? Thanks for coming.
Great, thank you.
Yeah. If you would, tell me, first of all, what inspired you to work in the particular area of sleep and health research? And then, let's talk about the research itself.
Yeah, there's a lot of reasons to be looking at the connections between sleep and health. When you think about it, sleep is something that's universal. It ties everybody together. It's something that everybody does. And the reason for that is because it plays a lot of important roles in a lot of different areas of functioning. And so when we're not sleeping well or we're not sleeping enough, there's a lot of different things that can become problematic, which makes studying the connections between sleep and health really rewarding because we can help people through getting better sleep to improve not only their health and how they're feeling during the day, but in order to make a real impact in their functioning.
So, there's a lot of things that can go wrong with sleep. Unfortunately, I've been through a lot of them myself. But what are the particular things that you study? Do you focus on apnea? Do you focus on not enough sleep, or when you sleep? What in particular are you looking at?
Yeah, mostly we're looking at real-world connections between sleep and health and how people sleep in the real world, what impacts that, what they can do to improve that, and how it impacts outcomes. Most of the time I've been focusing on how much people are sleeping because it's relatively easy to measure. How well people are sleeping is a little tougher, but we're looking at that as well. And then another dimension is timing, and another dimension is disorders. Like you mentioned sleep apnea and you mentioned insomnia. We do some work in that area, but most of what we're doing is looking at people without sleep disorders or who may or may not have sleep disorders, and how are they sleeping, how much are they sleeping, when are they sleeping, and what's getting in the way of their sleep.
Well, it seems like with the amount of time someone sleeps, it may not be accurate because everyone has a different, sleep onset. This comes to mind because I see advice a lot. Oh, it's good to take 20-minute naps, But I always think, well, what if it takes me 20 minutes to take a 20-minute nap and fall asleep? So
right.
When you study how long people sleep, I would think you'd have to, do they just self-report, or do you have them in the lab and you watch how long it takes for them to fall asleep?
It depends. There's a range of ways of measuring it. Now, going from the most broad and subjective, where you're just sort of asking people, to the most objective and precise, which is where you're measuring people in the laboratory. Now, there's lots of technology in between, and there's lots of different ways of assessing and estimating, ranging from the more subjective to the more objective. But the reason why we have so many tools is because none of them is perfect. You can have the most precise measurement of sleep in a lab, but in order to get that, you have to hook people up to lots of wires and have them sleep in a lab. And that will change how they sleep. So, and then if you ask people how they're sleeping, well, it's probably a reflection of what's going on outside the lab, but how accurate is it? How precise is it? And so there's usually these trade-offs. And what's great is there's lots of emerging technology, whether it's movement-based or using other biological signals to estimate sleep objectively, but relatively unobtrusively. And that can help us get a better picture of what's going on in the real world.
Yeah, it's funny. It brings a question to mind. How do you know when someone's asleep? What's the formal definition? My wife says, "Oh, I'll just stop answering questions," and she knows I'm sleeping or my breathing will change. But how do you or how do scientists say, okay, that person's asleep? And are there stages that they go through before they fall asleep? And do they have names?
Yeah, so sleep is one of those things that it's hard to define specifically, especially when you're observing somebody, because there's lots of changes that happen in the brain and in the body during sleep, but they're not readily observable. I mean, you can't see someone sleeping and know what's going on. If you're looking for a definition of sleep, it's a state, or it's a collection of states actually, that's naturally recurring, which is a very important element to it, because you have other states of altered consciousness, but they're not naturally recurring. It involves decreased perception of the environment, but you're not totally cut off, but it is decreased. You have decreased awareness and consciousness. Again, not 100% removed, but it's dramatically decreased. You have different patterns in what's going on in the brain and in the body. You have different things that are happening during sleep. So, for example, you're talking about the brain in sleep stages. There's different brainwave patterns that occur during sleep than occur during wake that underlie some of the functioning that's going on. But there's other things that are different in the rest of the body too. So, for example, most people have heard of growth hormone. This is what our bodies secrete, not only to grow, but it's also very involved in cellular repair and rebuilding. That's pretty much only secreted during a specific type of sleep. So there's lots of things that happen throughout the body and throughout the brain that are very sleep specific. But when you're observing somebody, usually the only ways you can tell, if you're just observing them, you can see, is their breathing changing? Is their heart rate changing? Are they not moving? Are they not responding to the environment? Is it at a time when you would expect them to be sleeping? Things like that. Using some of the objective measures. So you have the brainwave technology, where you can look at different patterns of waves that exist during sleep that don't really exist when you're awake, and you can tell that way. There's also using movement and heart rate. So, for example, a lot of wearables can use movement tracking to estimate sleep, and that's because when you're asleep, the type of immobility you have is different from just, say, sitting on the couch. And if you have a device that's sensitive enough and calibrated enough, you can tell with, right now the devices that are out there can get up to about 95% accuracy on a minute-by-minute basis to determine, does this movement-based detection agree with brainwaves? And on a minute-by-minute basis, you can get about 95% accuracy on movement alone with some of these algorithms. And then when you add in heart rate variability, because now you have technology where you can measure heart rate continuously, and when you combine those together, it can be even better. So there's all kinds of different things that we can use to estimate sleep. Now, we can't measure sleep directly because sleep exists deep in the brain. And so if the only way we could measure sleep at the source is if we were, say, putting probes in people's brains. We can't do that. So what we have to do is we have to measure around it. We have to guess at it based on other measures. Things like movement, things like brainwave activity, but those aren't what sleep are. They're just things that happen that are tied with sleep.
Okay. Maybe a few facts or surprising statistics or learnings that you know about sleep that other people don't because you study it.
Yeah, so a few interesting things about sleep. So number one, if you go back to the 1960s, when the first community level health studies on a large scale were done, these were the studies that identified, for example, that smoking was associated with dying sooner. Things like obesity was a big problem. This is where we get calculations for body mass index from these from these old original studies. If you go back to those studies, there were 5 aspects of lifestyle that were identified as the leading causes of people dying sooner. And it was in order: smoking, poor diet, lack of activity, lack of sleep, and alcohol. And we've talked quite a lot about all of the other ones except for sleep. It's just that sleep sort of fell off the radar. So one thing that a lot of people don't realize is this is something we've known for quite some time. We've known that sleep is related to how long you're living and how healthy you are and all of these things. It's just, I don't know why, culturally it sort of fell off the radar. And so that's one thing that people may not know, is that we've known this actually for a while. Another thing that people may not realize about sleep is it's actually a very, very active process. So people often see sleep as this sort of state of rest, where, during the day is when you do things, and sleep is when you're taking a break from doing things and you're recovering and you're resting, and it's very passive and you're conserving energy. Well, your body does burn fewer calories when you're asleep versus when you're awake and just sitting there, but not much fewer. Um, actually, um, actually, we burn a lot of calories when we're sleeping because our body is very busy. So our brain is very busy in terms of organizing information, processing information, regulating emotions, storing short-term memories into long-term memories. All those sorts of things that go on in the brain during sleep are very important and very busy. And part of that's where dreaming comes from. In the body, too, the body's still pretty busy. Your muscles aren't moving around, but your cells are actually quite busy in terms of building the raw materials and transporting them to where they belong so that your body's better prepared for the next day. So there's actually a lot of activity going on. And when you're not able to get good quality sleep, even if you're getting enough, if the sleep that you're getting is too shallow, then what that can do is that can result in all of these things not happening properly. So that's something that a lot of people may not know about sleep is just how active of a process it is. It's that people tend to see sleep as unproductive time and recovery only. But it really isn't. It's actually a very productive time. Your body's actually doing a lot of important things. And then a third thing that a lot of people may not realize about sleep is that if someone's having trouble sleeping, the number one thing that they should do is to get out of bed. And we have decades of data that show that no matter what causes a short-term insomnia, the main cause for long-term sleep problems is people staying in bed when they should have been getting up. And the reason is when you stay in bed fighting with sleep, what happens is you start building this relationship with the bed where you start subconsciously learning that the bed is the place to be awake and think and toss and turn and worry and all these other things, not the place for sleep. And so it eventually gets to the point where someone says, well, I'm really tired. I get into bed and I can't just slow my mind down. Part of it is because they're spending too much time in bed awake and they've trained their brain to do that. So if you can't sleep, actually getting out of bed, taking a break from trying to sleep, and then giving yourself some time and going back and trying again in a little bit is probably the best thing to do long term to prevent a more long-term sleep problem.
Oh, very interesting. Okay, that's helpful. So what in particular are you studying right now, and what stage are you at with it?
Yeah, so we've got a number of studies going on right now. One of them, what we're doing is we're doing a large community-based study here in southern Arizona, right by the U.S.-Mexico border, actually, where what we're doing is we're going into the community and we're looking at how sleep plays a role at the intersection of social environment, things like stress, access to care, diet, exercise, social functioning, all the things about all the elements of social and environmental stress, and then aspects of what we call cardiometabolic functioning, where this is kind of your how your body is functioning, looking at your heart, your blood vessels, your metabolism, how your body manages energy, obesity, inflammation, how all these things sort of tie together. And we're looking at the role of sleep at the intersection of those, because we've known for a very long time that, for example, stress is a leading problem in developing heart disease. But what we don't really know is how that happens and why that happens and what we can do about it, besides, try and be better about stress. And what this study is going to do is look at how it is that how you live your life and how you're stressed and how you're trying to get through from one day to the next, and how all those stresses come together to impact your sleep, and then how that changes sleep in such a way that sets you up maybe for worse health, where if you're dealing with some of these issues, like a lot of people are in terms of managing work and kids and finances and all of these things, and we take all this on, and it impacts our ability to get a good night of sleep. And then not only are there other health issues, but the lack of sleep itself starts leading the body to not be able to manage stress as well, but also not be able to be in as good health. And so what we're looking to see is what exactly is going on under the hood and how are these things all connected, which will tell us our next step, which will be, okay, what can we do about it? Now that we know where the problem is and how to deal with it, that's what we're going to do next. So that's one project. Another one you might be interested in is we're looking at developing some new technology which can help people who aren't getting enough sleep out in the world. How do you get more sleep of good quality while balancing all of these demands? And so what we're working on is developing some technology that can analyze your current behavior and your current sleep patterns and use that information to predict what the next step should be, and in such a way that you can make measurable changes in your life. Because most people, when they say, I'm not getting enough sleep, and when you ask them why, it's not because they don't like their sleep, it's because they feel like they can't. And so what we're working on is some technology to help predict how to bridge that divide, how to get people better able to make those changes using things that they actually do have control over. They may just not realize it. We actually have a few different projects in this area going on where we're trying to get this stuff out into the world and actually make an impact on people.
So could you say, is it fair to say the top three most important things about sleep is enough time to do it, your mental state or the right mental state, and then the right environmental factors like a dark room versus not a dark room, a quiet place, a noisy place, white noise, no, et cetera.
Yeah, I think you hit on that. I think you hit on an idea that a lot of people, I think, intuitively know but forget, is that sleep isn't something that you can make happen. Sleep is something that can happen to you if the situation allows for it. If you're in a situation that won't allow for it, if it's the middle of the day and it's bright outside and you have lots of energy, the situation is not really conducive to sleep, no matter whether you want to sleep right now or not. If it's nighttime and your room is too bright or it's too noisy, even if you're really tired, you can fight sleep all you want, but it's not going to happen because the situation is not allowing it to happen. And so that's why you get out of bed when you can't sleep, because the only thing you can change is the situation. You can't make yourself sleep. All you can do is change the situation. And so if you are not in the right mindset, if you haven't given yourself enough time to wind down, I mean, people do this. We're busy and distracted and doing all these things during the day, and then we expect to get into bed and turn a light switch off. It's not like a light switch. It's more like a car with brakes, where the faster you're going, the more space you need to give yourself to slow down when you press on the brakes. And so if you're not giving yourself enough time, you're not going to be able to fall asleep right away. There's nothing you can do to force that to happen. What you can do is impact the situation, create an environment mentally and physically in the environment that will let sleep happen. And when you think about what is healthy sleep, usually there's a few dimensions, and it's a lot like food. If you don't eat enough calories to support your body's functioning, I don't care how healthy those calories are, they're not enough. Okay, you're consuming enough calories, that's not the problem. Now, what's the nutrition in those calories? That's the quality of your diet, that's important too. And then if you're consuming enough calories, but not too much, if you're getting decent nutrition, doesn't need to be perfect, the next dimension of diet you look at is timing. Are you eating meals at the right time? Are you eating them at regular times? Is your body sort of on a regular system of metabolism? And that's the same way with sleep, where one question is, are you getting enough? If you can get 4 hours and it's really good quality, it's probably, I don't care how good the quality is, the quantity is probably not enough. Okay, if you're getting enough, if you're getting, the recommendation is for at least 7 hours for a typical adult. A lot of adults aren't getting that, but let's say you're at 6.5 hours, where we don't know a whole lot about 6.5. We know less than 6 is probably not enough for the majority of people, but okay, you're getting as much as you can. Might not be quite enough, but okay, what's the quality like? Are you struggling to sleep? Are you waking up a bunch during the night? Are you waking up feeling tired and exhausted, which is a sign that something was going on that interfered with the quality? That's the next question. And then once you have those, then we start asking about timing, where when you sleep, it actually can play a role in health as well, which is why shift work can be very dangerous, where it can impact everything from obesity and heart disease to cancer risk, because of all the different clocks in our body that are trying to keep in sync. And when we're sleeping at a time on a regular basis that's out of sync with where our body's expecting it, a lot of those functions don't work properly. So I guess that's my long-winded answer to your question. I think you're right that the three most important things is, one, get enough of decent quality. Number two, make sure if you're going to sleep well, you need to be in the right mindset. That usually means giving yourself enough time to wind down. And number three, it's having a healthy environment for sleep, where, if the environment is keeping you from sleep, that's something you may or may not be able to control, and that can have a profound impact on a nightly basis.
If there was just the two factors, environment and mindset, what weight would you give to each of them in when you are trying to evaluate the cause of someone's sleep problem? Is it more environment or is it more mindset? Like, what do you just see anecdotally, quick percentage, throwing it out there?
It's probably more mindset. I think people can sleep in all kinds of environments. Some people are very sensitive, but a lot of people who are very sensitive to the environment, it's not as much about the environment as it is about their sensitivity. So some people are very hyper reactive to the environment, partially because they're very mentally on edge, where that's sort of a combination of two things, where they attribute it to, well, I can't sleep because, there's these noises. It's like, okay, well, how about use some earplugs? Well, I can't use those because I'm too or whatever. There could be all kinds of things in the environment that people can sometimes get some control over. But, you've tried earplugs and an eye mask, you block out the light and the sound. If that doesn't work, it might be something internally that's causing you to be more awake that you're just attributing to the environment. So I guess, and also by the time I see patients in my clinic, they've already tried all that other stuff. They've usually gone online and Googled, how do I sleep better? And sometimes they'll get a new mattress, or they'll put blackout curtains on their windows and do all these things, which could be very helpful, but it didn't fix their problem. So by the time they come to me, the environment isn't really the issue anymore, even if it was at first. And all the people for whom it was, I end up usually not seeing them in the clinic because they fixed their problem.
Makes sense. Okay. What about the phenomenon of larks versus night owls? Do you think that's real, or is it just a person saying, like, hey, I identify this way and I like to stay up late, or I like to get up early?
Yeah, there's a thing called chronotype, which is partially genetically determined, and it's a marker of where in the 24 hours you are. Where in the 24 hours of the rest of the world is your internal clock. So some people, are people who we would call night owls, or, scientifically we call them a later chronotype, where they function better later in the day. It's harder for them to fall asleep earlier, and it's harder for them to wake up earlier. As opposed to people who have a very early chronotype, we call them larks or whatever. These are people who function very well earlier in the day, very poorly later in the day. They tend to fall asleep much easier if it's earlier, and they tend to wake up much easier if it's earlier. Part of this is genetic. Part of it is also age, where teenagers biologically almost always have a later chronotype, which seems to peak in the early 20s in terms of lateness, and then it can start drifting earlier and earlier and earlier as people get older. And then you have people who are much older who can have a very early chronotype, where they can go to bed quite early and wake up at 4 or 5 in the morning and feel fine. And these are the same people when they were 20, they were staying out till midnight. It's just, it can change across the lifespan. It can also be programmed, where light will reinforce a chronotype. So light is a daytime signal. So if you wake up in the morning and you get very bright light, even if someone with a later chronotype might be able to shift themselves to be able to function better during the day if they're able to get enough bright light in the morning and avoid the bright light in the evening, which would be keeping them up. or someone with a very early chronotype who's too tired too early, you give them bright light in the evening, it can help them stay up a little later, and avoid bright light in the morning, and can help them sleep in a little later. And so what ends up happening sometimes with people who could be extreme evening types, what happens is maybe they're biologically an evening type where instead of going to bed at 11, their body wants to go to bed at 11:30 or midnight, or maybe 12:30. So they stay up until 11 or 12 with bright lights on. So their body's not ready to go to bed at 12 or 12:30. It wants to stay up till more like 1 or 1:30 because, your light was suppressing your melatonin and shifted you even later than you already were. And then they stay up until 1 a.m. with the lights on, which pushes them even later. And so you have people who are going to bed at like 2, 3 in the morning when they say, well, I can't help it because I'm a night person. It's like, well, you might be a night person, but you actually might be more extreme than you really are. We might be able to shift it and move it. We do this in clinic all the time, actually, where people are having trouble keeping a schedule that works for them. And so we use things like light to help reset people's schedules.
Yeah, I'm an example of this. I've been going to bed at like 3 or 4 in the morning for like 20 years. And whenever I go on vacation, I'll have to get up early, and I do it, and it's easy. And then when I come back, I slip back into this pattern. And there's like, I don't know, when I thought about it, there's all these like psychological reasons why I do it. But it's just weird. It's just hard for me to do that. And my father's the same way. He's been doing it probably for like 50 years, 60 years. So it is a tough thing. It's like, I don't know. It's just funny that it's so hard, but it's definitely a phenomenon.
Well, it's sort of like when the clock on the wall says midnight, what does your internal clock say? So for some people, it says 1 a.m. and they should have gone to bed a long time ago. For some people, it says 9 p.m. and they're not ready for bed yet. And it's just there's a synchronization issue where everyone else is. You're sort of shifted over one way or the other. And there is actually quite a bit of genetics underlying that because, these are the genetics of the clock. And in the body, there's lots of these clocks because they're all in sync with each other, trying to help a lot of these systems in our body work together and work in sync with each other. And that's how our immune system interacts with our metabolism, which interacts with cholesterol synthesis, which interacts with, lung function. All these things are connected. And a lot of ways that they're connected are through the clocks and through timing. And so there's a whole biology to clocks and timing in the brain as sort of the central timekeeper, but also all throughout the body and lots of different organ systems. They have their own clocks. And these clocks they're genetically determined. They're part of the instruction manual of building you. So as the genes may differ from person to person, how these clocks get expressed might also differ.
Yeah, I've always wondered
plays a role in health.
Okay, we'll get into that in just 1 second. I just have one quick question. I've always wondered this. So, like I've seen science say, oh, cortisol peaks at or it goes to this lowest point at 4 a.m. and it peaks at this time, but I never see any of this scientific data taken to affect your actual sleep. So if someone goes to bed at 10 p.m. and gets up at 6 a.m. every day, what do their hormone levels do versus someone that goes to bed at 3 a.m. and gets up at 11 a.m. every day? Do the hormone levels still peak and go down at the same times, or do they follow the person's sleep?
Some of them do. So there's two different systems. There's a sleep-wake regulation system, and there's a circadian system, which is the 24-hour clock. There's some organ systems that are 24 hours no matter whether you sleep or wake or where you sleep or wake. It just cares about where in the 24 hours it thinks you are. But most of them, sleep-wake is a major piece of information to the clock that it's using to help adjust itself. And so you're exactly right that all of these rhythms, you can change them. So for example, testosterone peaks in the evening. I mean, so, this whole thing of like, at what time? Well, at what time for who? I mean, you're talking about on average across people in a laboratory who are usually young, healthy 24-year-olds with no medical history. Like, out in the real world, it's a little bit messier, but testosterone peaks in the morning and is sort of at its lowest sort of in the evening. And there's this rhythm to it, and you can, if you track it over time. And
Okay, yeah, I just wondered how
shift,
that changes with different sleep cycles. So.
right. So if you take somebody and not only can you shift the rhythms, whether it's testosterone or another hormone, you can shift the rhythms earlier or later by changing your sleep schedule, but you can also change the shape of the rhythm. So, for example, testosterone's a great example where if you take someone and actually don't shift where in the clock hour they're sleeping, but you change the amount that they're sleeping, then you can actually blunt the entire rhythm. Same thing with leptin, which is a hormone that controls satiety, where if you have this natural big rise in leptin, like right after meals and then during the night, it has a big rise. That's what keeps you from being hungry all night and eating, usually. But if you change where you're sleeping, if you say sleep later than usual, you can alter the timing of this rhythm and sometimes even eliminate or even reduce it across 24 hours. So a lot of these hormone systems you can shift and change. They're constantly responding to where your body thinks it is. And when you change your sleep-wake cycle, you're changing where these different hormone systems are. And not just hormones, but neurotransmitters and all these other systems that are all connected. That's where seasonal affective disorder comes from. And winter blues and winter depression, as the light-dark pattern changes and we get less light during the day, that light-based information to our internal rhythm gets altered, and a lot of these systems start getting out of whack a little bit. They start becoming somewhat desynchronized, maybe, or becoming slightly less efficient because they're not exactly sure where daytime was because there was no huge bright light pulse, for example. And that's why you can treat it with bright light. And you can treat winter depression with light because it's a circadian issue.
Hmm.
So you're exactly right.
Okay, and in your body, are there light? I mean, there must be light sensors, I know, in your eyes. But what about other parts of your body? Can your entire body sense light, or just your eyes, or do you know?
Well, so there's parts of the body that sense light, but for the clock and for the rhythm, it's all through the retina. It's all light through the eyes. There was people have explored shining light on different areas to see if it can impact circadian rhythms at all, and it looks like it just doesn't. It's through from the retina into the brain. There's actually a direct connection from the retina to the brain that's more direct than from the retina to the visual system. And so it's actually the first stop that the optic nerve makes when it hits the brain is actually the clock, not the visual system. So it's a very important system that you have, which is why sometimes you see commercials for a non-24-hour circadian rhythm disorder in blind people, because they have, humans are great. We have our own internal 24-hour clock that doesn't even need light, but it's not precise. It's biological. It's a little messy, and we use light to regularize it. And if you're blind in your retina and you can't get that light from your retina to the brain, even if you shine light, even if you're in light, your brain won't know that there's light, and so you'll be going on your natural rhythms, which will sort of start drifting because they're not perfect, they're not precise, they're built to use light information to synchronize. And when you don't get that information, so that's why they have there's medications now that that mimic melatonin. You can give someone a 0.5 milligram of melatonin, and if you time it at the right time of day, one dose can regularize their rhythms because it gives them because light suppresses melatonin, and when you and the melatonin rhythm is part of this whole system, and you can use that to bypass that system. And so blind people, often either have to take melatonin or some other medication or something that helps regularize their rhythms. It's through the retina.
It's interesting. Could you use
so it's interesting if you're
small
blind,
doses
if you're cortically blind.
Okay.
I was saying if you're cortically blind, where if you have a damage to the part of your brain that manages vision and you can't see, but your retina works fine, then your clock is fine.
Very interesting. Yeah, a thought just occurred. What if you're trying to reset your clock? You said you could expose people to light earlier and not expose them to light later. What about using doses of melatonin? Small 0.5 milligram doses at certain times to change your clock and to make you get tired earlier. Would that work, you think?
Yeah, we do that in clinic all the time, using light and melatonin. I mean, light and melatonin are essentially opposites of each other, where melatonin is a signal of darkness, and light will suppress it, which is why when you wake up in the middle of the night, you don't want bright lights around you because that'll suppress your nighttime melatonin. But the dosing and timing for melatonin can be very tricky, and sort of, the 30-second version is higher doses aren't necessarily better. Closer to bedtime may or may not be better. Too early or too late will have limited effects depending on the dose. So working with someone who actually knows how melatonin works might help optimize it. But the thing about melatonin that people need to understand is melatonin isn't a sleep inducer. It's not a sleeping pill. It doesn't. It's not very good at making you sleepy. It can make you a little sleepy, but it's actually pretty useless for treating insomnia. It's mostly a clock shifter. It's mostly something that can be used to tell your body that it's nighttime. And as I mentioned, higher doses aren't always better. You want the dose that's going to send the proper signal, and higher doses don't send a louder signal. If anything, the dose can be so high that the circadian system, it's out of range of what the circadian system is looking for.
So what does that do then if you have a too high of a dose?
Then you might get some side effects, and it might make you sleepy or it might make you drowsy, but you won't get too much more drowsy than if you took a lower dose. You'll just get more side effects from it. Maybe, for some people it upsets their stomach or their head. It could sometimes even gives people crazy dreams. It can do all kinds of stuff. Higher doses aren't necessarily better. As I was saying, 0.5 milligram is all a blind person needs to regularize their clock. They usually sell it in 0.5, 3, and 5. 5 is usually what you would need a little closer to bedtime since you're already producing some by then. But it's not a very good insomnia cure because most people who have insomnia, their body already knows it's nighttime and that's not the problem. But for some people, if it's a clock issue, melatonin can be very helpful if used properly.
What about the phenomena of the second wind? Someone's tired and then 10 o'clock at night, they get a second wind, they call it.
Yeah, that does happen. I mean, there's a couple different versions of that. One is you sort of have a dip in the afternoon in energy, and then it sort of comes back. There's usually a burst of energy sort of right before habitual bedtime. But then if you blow past your bedtime, you can get another wave of energy. I think that seems to be a very useful survival mechanism, where if you're running from the proverbial bear and it's past your bedtime, okay, something's important. I guess you need to be awake. And then sometimes, there might be a window of time where there's an optimal bedtime for you. And if you stay up too late, it might actually be a problem getting to sleep as well. Even though you're even more hungry for sleep than you were an hour ago, you have other things. Your alertness system might be starting to kick in. Because the alertness system and the sleep system are two different systems. They're supposed to go with each other, but there are times like this, for example, where your sleep system would be high, but then your alert system might start kicking in because it's saying, okay, you've missed your sleep window. Something must be really important, maybe, and maybe that's what's triggering it. I don't think the neurobiology behind that is known very well, but it's definitely a phenomenon we see in clinic.
Okay. And then, we should have gotten to it earlier. I'm sorry, but the health effects of sleeping at the wrong times, like you said, doing shift work, or what have you observed? Are there deleterious health effects by even just going to bed late? You're not even staying up all night.
I mean, even if you're not staying up all night, if you're going to bed too late on a regular basis, you may be fine. But people who tend to stay up much later, even if they feel like that's naturally what they should be doing, they're more likely to become depressed. They're more likely to become obese and have weight problems and heart and metabolic issues. And they're more likely to have functional problems during the day. Part of that may be due to, they're tired during the day or and other things related to that. But there's actually work showing that those genes that control your natural timing also control things like mood and thinking and some of these other things, and they could be bleeding over from one to the other. So when you have an extreme version of, say, a night owl gene, that same gene might also be related to depression risk or obesity risk, because if it's a disruption in your clock, and the clock controls so many of these things, that's where some of these things overlap. And that's why we have this issue called social jet lag, which is where you're not actually going anywhere. It's just by keeping different schedules during the week and on the weekends, you're essentially jet lagging yourself every few days. You stay up later, wake up later, and then you go to bed earlier and wake up earlier, and then you stay up later and go to bed later. And if we do that back and forth, that can take a toll on the circadian system, and it can start having some of these effects, whether it's in ability to think clearly, whether it's mood and stress management, whether it's energy level. A lot of these areas can be affected.
Okay. So, let's give a call to action, because we're getting close to the end of the time.
Sure.
What kind of people are you looking to help? What kind of issues will they have, and then how can they get in touch?
Yeah, so there's a number of people that I'm really interested in helping. So if for people who are struggling with sleep issues, we have a clinic. I'm also connected with a network of other people who specialize in sleep nationwide. The first thing I want to say is, if you're struggling with sleep, your problem may be solvable, and it may not be solvable by your primary care or someone who might not have much training in sleep. There's networks of people out there. Feel free to reach out to me, and I can connect you wherever you are. I have my own clinic, but I can, like I said, I'm in a network of many others. So don't struggle alone. If you're having trouble with sleep, there may be a solution for you, and a lot of times it doesn't require sleeping pills. That's number one. Number two, a lot of my work is focused on actually people without sleep disorders, people who are just trying to get through life, juggling job and stress and kids and work and school and all these sorts of things, and where you don't feel like you have enough time for sleep. People, some people travel a lot. Some people, their work keeps them up late. So I've worked with everyone from, executives to athletes and whoever, people with crazy schedules. We all have crazy schedules. And if I can help people to get better sleep, to get better control over their sleep, hopefully we can improve the quality of their life. And so the main thing I would say is take sleep seriously. See it as just like nutrition, just like exercise. It's something that your body requires to function properly. And don't make excuses for not sleeping. Don't see sleep as just rest, and that as long as I'm able to make it to work the next day, I'm fine. These things can catch up, and I think it's something worth taking seriously.
Okay, very good. So what are some literally, how do people find you? What's the web address? I don't know if you want to do email or social media, but how can they find you?
Yeah, you can go to michaelgrandner.com. Our lab is sleephealthresearch.com. I'm on Twitter at Michael Grandner. I'm pretty easy to find. If you Google my last name, I'll be pretty easy to find. Okay,
very good. Well, Michael, thank you so much for coming on the podcast. I appreciate it.
Thank you very much. And let me know when it goes on so I can have a listen.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.